we were
Good
discussing,
afternoon.
yes, good afternoon. We were discussing the force vibration. Okay. So, in the earlier cases, in the force vibration, so there was no vibration of the support. Okay, only the mass was vibrating. So here there is a case where we will be considering the vibration of the support also. Okay, because though the support is fixed, but it is not mandatory that the support may not vibrate. So sometimes the support can also vibrate, and we will see the effect of the support or the frequency of the support, motion of the support on the system. Okay, so here actually you can see in the figure, so there is a spring mass system with a damper, okay, or dashpot, a damping dashpot, which is the damper. So stiffness of the spring is K, and the dashpot, it is having a damping coefficient of C. So here you will see two displacement while displacing the body forcefully. So one will be the vibration or the motion of the support, okay, or the displacement of the support due to some external sources. Okay, so here let us consider the support equation, okay, equation of motion as y equals to capital Y sine omega t. Okay, it is considered to be a periodic, okay, a periodic sinusoidal motion. Y equals to Y sine omega t, and this is the equation of motion, and this is the representation of the displacement y. Okay, so in the downward direction while the body was moving in the downward. Okay, uh, so we need to write this one also while we will be drawing this kind of figure. So force vibration due to the excitation of the support. Okay, so now we are going to actually analyze this system, how actually this will behave. So for that, we will be seeing the equation of the free body. We will be analyzing the free body diagram on which the system will be experiencing the various forces on because of these motions, or because of this position of the system. Okay, so while the body was displaced in the downward direction x with a support of with a displacement for the support as y, so the spring was stretched. Okay, so the spring force will act, but there will be a relative displacement as
Sir,
well as relative motion. Yes,
hello.
yes,
Sir, someone is trying to join.
okay. Actually, the page should be open while someone is joining. That is why I am every time skipping to this page, okay, or to the screen while teaching. Okay, I think they have joined. Okay, we will do the same
Yes, sir.
thing. Yeah, when it is required. Okay, just go back. Yeah. So yeah, for the newcomers, I am just telling that today we will be analyzing a system where there will be a vibration of the support. Okay, earlier the mass was vibrating, so here the support is vibrating with a periodic sinusoidal motion as y equals to capital Y, magnitude of the motion, y sine omega t. Okay, so here this is the y, and here this is the x. So now we are going to find out what are the forces which are acting on this mass. Okay, so if you just see there will be a relative displacement because this is y and this is x. Okay, so if we will be finding out the absolute amplitude. Okay, absolute means what? Suppose the temperature of this room is absolute 30 degrees centigrade. So if it is asked as absolute, so what does it mean physically actually? So absolute means what is temperature basically? So in micro level, if you want to measure the temperature, just wait. So what is that actually? So the collision among the molecules. Okay, if you consider those collisions, from the starting of these molecules, okay, to the numbers, okay. Suppose there are 50 lakhs of molecules are there, so starting counting the collisions from the number one member to the 50 lakh member. So if you just add it up, then you will get the total temperature as 30 degree, okay. Means from zero level to the maximum, okay, or to whatever extent limit. So if you are counting, so that is called as the absolute, okay. So here we will be calculating the absolute amplitude, okay. So to calculate absolute amplitude, we need to find out the value of what? X, okay, because this is X. The equation will be X of sine omega t if there is no phase angle in between this equation and this equation, okay. So the forces which will be acting, if you are finding out the relative means this absolute amplitude, then the spring force will be K into X minus Y, because there is a amplitude for this vibration of this support, okay. And the damping force, what is damping force? So damping force FD equals to C into X dot. So generally while the body was moving in downward direction with a velocity of X dot, so the damping force is C into X dot. But here there will be two velocities, that is why one relative velocity you will get, that is X dot minus Y dot, isn't it? So C into X dot minus Y dot will be the relative this damping force which will be acting on this mass, okay, and the inertia force. Understood? So inertia force will be simply m into x double dot, okay, because you are calculating the absolute amplitude. Just okay. So when we will be putting this in a Newton's second law of motion, okay, so how the equation will become? So mx double dot, this is the inertia force, equals to the all the external forces you need to add it up, okay, on the right hand side. So this was the damping force in the upward direction, so that is why it is negative, minus of c into x dot minus y dot, okay. So as because there are two velocities, okay, one was the velocity of the mass, another was the velocity for the support, okay. Minus the spring force is also in the same direction of this damping force, so the spring force will be acting on the upward side, so k into x minus y, okay. So if you just simplify and if you just take the x terms on the left hand side and y terms on the right hand side, so you will, after a arrangement, you will get this one, mx double dot plus cx dot plus kx, and this one minus minus plus cy dot plus ky, okay, plus ky plus cy dot you will get on the right hand side, okay. Now what we will be doing, so we will keep these terms remains the same, mx double dot cx dot plus kx, and instead of this y, so what I will be writing, k sine omega t, okay. So instead of this y, we will be writing y sine omega t, so you just write it down, okay. So instead of this y, okay, so this k term will be there, so y sine omega t, okay. So if you make y common, so this will be k sine omega t plus c y dot. So what is y equals to y sine omega t, and then y dot will be, so y cos omega t, but one omega will come outside, okay. So that is why c omega cos omega t, means if you just differentiate this term, then what you will get, y omega cos omega t, okay. So from there y make just you take y common, so k sine omega t plus c omega cos omega t. I think up to this much it is clear to you, okay. So after that, what I will be doing actually, so I will be writing the same term on the left hand side, mx double dot plus cx dot plus kx equals to, so y, and this term k sine omega t plus c omega cos omega t, so I am writing in this way, okay, under k square plus c omega square sine omega t plus alpha. So will we be able to write this one into this form? So how this is done actually, so I will show you, okay. So just you can take one page and paper, you can note it down. So from here, so this is written, okay. So by applying some trigonometry, so we'll be able to write this expression as this one. So basically what actually we are going to find out, we are going to find out the value of x, capital X, okay, absolute amplitude, okay. So how we will do that, I will show you, yes. So you can see mx double dot cx dot plus kx. So y k sine omega t c omega cos omega t. Okay. So here, so this is the free body diagram. Okay, just a rough drawing I have drawn actually. So from here, what I will do, so y I will make it common. So instead of this term, I will be writing, I will be making common under root k square, this coefficient and this coefficient, c omega square, c square omega square, a square plus c square omega square. So in bracket, what term will remain there? So this is extra term, that is why we need to divide this term by the same term. Okay. So sine omega t will be remain same. So it is correct, no problem, because if you just cancel these two terms, it will be remain k sine omega t. So k sine omega t plus c omega is already there. So there is no under root k square plus c square omega square. So we will introduce again this term, okay, in the denominators, and then cos omega t. Okay. Now what I can write, y, so I will be writing this one, and instead of this one, you can see I can make one triangle. Okay, right angle triangle of side k and this one, k and c omega. So k and c omega, and the angle is alpha. So in between these two sides, the angle is alpha, and the resultant will be given by Pythagoras theorem, k square plus c square omega square. Okay, so what is k by under root k square plus c square omega square? K square plus c square omega square. So this will be cos alpha. So if you just find out what will be cos alpha, then k divided by this one will be cos alpha. So instead of this, I will be writing cos alpha. Okay, so c omega under root k square plus c square omega square. So it will be sine alpha. So I will be writing sine alpha. Understood? So cos omega t term will be remain there. So instead of this y, and we will be writing y, and for this we will be writing the same term, and here you can see that this is sine a cos b cos a sine b. So sine a plus b. Okay, sine omega t plus alpha I can write, isn't it? So this is correct. So instead of this term, whatever it is on the it is there, so I can write in this way. Okay, so this is the simple simplification for this calculation. Understood? So they have given directly. So you just go through those points, so which I have mentioned, and finally you will get this one. Understood? So where, what is alpha? So alpha you can find out from this triangle directly. What is alpha? So alpha tan inverse c omega by k. Okay. So tan, if you just calculate tan alpha, then it will be c omega by k. Okay. So alpha will be tan inverse c omega by k. Okay. Now, yes, c omega by k. So tan inverse. So what is c omega by k? In the last class, so we have solved. So 2 zeta omega upon omega n, isn't it? So in the last class we have seen this one, c omega by k. Instead of c omega by k, we can write 2 zeta omega by omega n. Understood? Now, what was our steady state of solution actually? So our steady state of solution was this, was x equals to, so in the particular integral type. Okay, in the solution in the particular integral type. So this was our actually amplitude, isn't it? This was our amplitude, and how we actually found out this amplitude in this vectorial form. Okay. Yes, this is c omega by k. Why it is 2 zeta omega by omega n? So it is there in the last class we have seen. So here you can see. So what was our solution? This was the xp, and this is the steady state solution. So x of st and divided by this, all these terms, sine omega t minus phi, isn't it? Now we will comparing this with this one. So yes, omega t minus phi. Now what is omega t? Here now the omega t plus alpha it is there. That is why the steady state solution now it will become x equals to x sine omega t plus alpha, because here the angle is omega t plus alpha. Earlier it was omega t. That is why omega t minus phi. But here angle is omega t plus alpha. That is why omega t plus alpha minus phi. Okay, so both term will be near alpha and phi. So this is the actually representation of the steady state solution. Okay, so for this system also, just like our previous solution under the force vibration, where we didn't consider the vibration of the support. Okay, so where x is the steady state amplitude, this x is the steady state amplitude, and we are going to find this x only. Okay, and is given by the equation similar to this one, from where this equation actually comes. So from the last derivation, here you can see This is just like f naught. Okay, earlier there was f naught sine omega t. If you can remember, mx double dot cx dot plus kx equals to f naught sine omega t. Okay, so instead of this f naught, here it is y under root k square plus c omega square. I can show you the same thing. Here you can see, yeah, yes, f naught. Okay, so f naught term was there. X equals to f naught. So instead of f naught, here this one, this term it is there. Okay, instead of this f naught, here this term is there, y under root k square plus c omega whole square. Okay, and this one will be remain same. So if you just rearrange, so if you just transfer this y to the left hand side, it will be x divided by y. Okay, and what is x? If I will ask you what is x, so this is the amplitude. Okay, absolute amplitude. And what is y? So this is the amplitude of vibration of the support. Okay, so this is the amplitude of vibration of the support. So this will be, if you divide it by k, okay, so c omega by k whole square. So c omega by k, I told you this is 2 zeta omega upon omega and whole square. Okay, so that just you need to divide it by k. So 1 minus m omega square by k. So again you need to write omega by omega and whole square, then full bracket, then you need to give the square. Okay, because square is there. So for c omega by k, so this is 2 zeta omega by omega and again. Okay, so under whole square. So this is the actually expression of this amplitude, steady state amplitude for this vibration of due to the vibration of the support. Okay, so you can see one thing, and this is the angle. So angle will be directly given by this divided by this. You can say this divided by this. So tan inverse 2 zeta omega upon omega n. So you know all these things because in the last class it was discussed broadly. Okay, so then this divided by 2 zeta omega by omega n upon 1 minus omega by omega n square. Okay, so you need to practice and you need to write on paper, otherwise you will forget. Okay, and in the exam what will happen? So you will fill blank. Okay, some of the formulas will look similar. That is why sometimes it is very much confusing. Okay, so and to solve to actually overcome this problem, so you need to write each and every formula for numbers of times and comparing equations. Okay, so this is phi and alpha, you know. Okay, because we have already found out alpha from this figure. From this figure we have already I showed you. Yeah, already we know what is alpha. Okay, so alpha will be tan inverse is by this. Okay, so you can find out the value of phi minus alpha. So phi this one, alpha is this one. Okay, so now from here actually this expression, so one thing you can actually see that when actually omega, this omega, what is omega? This is the excitation, okay, or the frequency of the support. Okay, motion frequency of the motion of the support. So if this is very much less than this one, omega n, if this is very much less than this one, so x by y, so this term will vanish, isn't it? If this is very much small, in comparison to this one omega n, so this will vanish, so only one will be remain there. So x by y will be equals to 1. Okay, or the complete system moves and the body will move, the system, complete system will move as a rigid body. Okay, at very low frequency. But when omega is very greater than omega n, you can see when omega is very greater than omega n, then x by y, so it will be equals to 0, or you can say the body is stationary at high frequency. Okay, so the body will be very much static. It will look very much static. Okay, or very stationary at high frequency. Okay, and the ratio x by y, which is given by this equation, it is called as displacement transmissibility. Okay, so you need to remember this term. Here it is not mentioned. So this term x by y, it is called as displacement transmissibility. Okay, displacement transmissibility. So you need to remember this one. Sometimes the question it is asked that what is the displacement transmissibility from the following? Find out the displacement transmissibility from the following. So options will be given and you need to select this option. Okay. So this is all about your force vibration due to the excitation of the support. Okay. So I think that this is not that tough thing to actually analyze. So if you know the previous analysis, that is normal force vibration analysis, you will be easily able to execute this one also. Okay. So today I will actually show you another problem. Okay, on this topic, particular topic. Then we will stop. Okay, and then we will. Yeah, I will be giving you these notes also in the WhatsApp in the Google Classroom. So yes, the support, this is the problem. The support of a system, spring mass system, is vibrating with an amplitude 5 mm. So what is 5 then? Capital Y will be 5, isn't it? Because this is the amplitude of vibration of the support and a frequency of 1150 cycles per minute. Okay. The external frequency is given, support frequency is given 1150. It is given. Okay. But it is given in what numbers of cycle per minute. Okay. And we are having the frequency in omega, isn't it, radian per second? So we need to convert this n term. Okay, this is capital N actually. So if the mass is 0.9 kg, so mass is given, the spring is a stiffness K is given 1960. If it is not clear, okay, so it is 1960 Newton meter. Okay, Newton per meter stiffness. And determine the amplitude of vibration of the mass. So we need to find out capital X. So what amplitude will result if a damping factor of 0.2 is included in the system. So this is the second case. So first we are going to find out X, okay, under this given condition. Capital Y is given, N is given, okay, so N for omega is given, mass is given, spring stiffness is given. So we'll be writing all those things. M is given, K is given. What is omega m? So K by under root K by m, because this is linear vibration. So under root K by m will be your omega m. So omega m will be simply this one. Okay, and what will be omega? Because n is given, so 2 pi m upon 60. So this will be your omega, external frequency. Okay, external frequency, external source frequency. This will be 120.3 radian per second. So this fraction you can find out, because in the formula only this fraction will be used. Omega upon omega and 120 by 3, 46.7. So this will be exactly 2.58. Now there is no condition for zeta. Okay, and secondly, this condition is put that zeta equals to 0.2. That's because there is no condition for zeta, so we will consider zeta equal to 0. Okay, and we will be putting x by y. Okay, because x by y was given in this equation, x by y. So 1 plus 2 zeta, zeta is 0, so this term will be 0. 1 minus omega upon omega, and this ratio we have found out, and this value will be 0. So simply we will be taking modular sign. Okay. Otherwise, sometimes it may come as negative because of this direction. Okay. So that is why just take the mod sign. Whatever negative value will come in, those will be converted to positive value. Okay. 0.886. So if you just calculate, it will come as 0.886. Means with an amplitude of this much, so this body will vibrate under this amplitude of this support 5 mm. Okay, and if the zeta value is taken as 0.2, then your amplitude, okay, so this amplitude will be this one, so x upon 5. So as because the zeta value it is there, so the second term will be having some value, 2 zeta omega upon omega, and it will be having some value. So you need to put it here. Again, this one, same thing. So you will get x equals to 1.25 millimeters. So very simple problem. Only you need to remember this formula. Okay, and how this formula will come. So you need to know all these things. Okay, this concept here, whatever the mathematical these arrangements were actually done. So you need to remember all those things. Okay, so thank you, dear students, for listening. So if you have any doubt, so you can ask me, and just wait. I will be taking your attendance. If you have anything to ask, you can ask me. Okay. Okay, thank you. So you can leave this meeting if you don't have any doubts.